Um, Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter sets and uh, relations. So any doubts if you have in any steps of the solutions, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, in any other chapter of maths, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of maths will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here in the first question, it has been told that let A is a set. A is a set which contains element 2, 3, 6, 8, 9, 11, and B is a set which contains the elements 1, 4, 5, 10, 15. Then and let R be a relation on the set A cross B. So R is a subset of A cross B, which is defined by the order pair A comma B is related to C comma D if and only if 3AD minus 7BC is an even integer. Then the relation R is. So we have to find if it is symmetric, reflexive, or transitive. Since if it is reflexive, symmetric, and transitive, then it is called as an equivalence relation. So the rule is that for reflexive, the rule is that A comma B should be related to A comma B. Now which so A comma B, if it is related to A comma B, it means that 3AB minus 7BA, that will be equal to minus 4BA. So which will be obviously an even integer only. So it means that it will be a reflexive relation. It will be obviously reflexive. And for symmetric relation, we should have that that if A comma B is related to C comma D, then this implies that C comma D also should be related to A comma B. So mm, now if A comma B is related to C comma D, it means that 3AD minus 7BC is an even integer. So this is an even integer only. Now, if C comma D also is related to A comma B, it means that 3CB minus 7DA it should be also even. Should be also even. Now, this so this we can write this will be actually 3AD minus 7BC. So now this you can write this will be 3AD minus 10 3AD, I can say 3AD minus 10AD, that will be minus 7AD, and minus 7 BC plus 10 BC. So therefore I can write this will be 3 AD minus 7 BC minus, or I can say plus 10 into BC minus AD. So BC minus AD will be some integer only, and into 10 is an even integer. So it means 10 into BC minus AD. This will be also an even integer only. And 7 a and here as we have showed that 3 AD minus 7 BC is an even integer, whi- which was our assumption. So this was our assumption that 3 AD minus 7 BC is an even integer. So this is also even integer. So even number plus even number, that will be also an even number only. So it will be even integer. So hence, therefore, the relation R is symmetric also. Symmetric also. Now transitive, for transitive, the rule is that if A comma B is related to C comma D and C comma D is related to E comma F, then A comma B A comma B also should be related to E comma F. So here we have to assume that A comma B is related to C comma D and C comma D is related to E comma F. And using that, we have to show that we we have to find if A comma B is also related to E comma F or not. So if A comma B is related to C comma D, it means that 3 AD minus 7 BC is even integer. And also if C comma D is related to E comma F, then it also implies that 3 CF minus 7 DE is also an even integer. Now, so let's say we take, this is some integer, let's say 2n, and this is also an even integer, let's say that is equal to 2m, where n and m where n and m are some integers. N and m are some where n and m are some integers. Now, therefore, A comma B related to E comma F if 3 AF minus 7 BE, that is also even. So this we can write 7 AF 3 AF minus 7 BE. So let's say this is AF minus 7 BE. So here we can't say that if it is even or not. Let's say we take A as 2. Let's say suppose we take A as 2 and B as 5, and it is related to 6 and 8. Since y, as you can say, 3 into 2 into 8 minus 7 into 5 into 6. So that will be 3 8 6 8 is a 48 minus 3210. So that will be obviously even number. Since y even minus even, that will be even number. And suppose we take 6 comma 8 is also related to 9 comma 4. Since y, that will be 3 into 6 into 4 minus 7 into 8 into 9. So even number minus even number, that will be also even number. But here, if we take 2 comma 5, 2 comma 5, and if it is related to 9 comma 4 or not, we have to check. So then it will be 3 into 2 into 4 minus 7 into 5 into 9. So this is even number minus odd number. So it will be an odd number, which is not even number. So hence the relation R is not transitive. Relation R is not transitive. So therefore the relation R is reflexive and symmetric but not transitive. So option C is the correct answer. Then here it is told that let A be the set. Yeah. Let A be the set 1, 2, 3, 4, 5, and R be the relation on A. R is a subset of A cross A. So R is a relation on A defined by X is related to Y if and only if 4x is less than or equal to 5y. So let m be the number of elements in R and n be the, so m is the number of elements in the set R and n is the minimum number of elements, minimum number of elements uh, from the set A cross A. So m is the number of elements in R, the set R. And n is the minimum number of e- elements in the set A cross A that are required to be added to R to make it a symmetric uh, relation. Minimum number of elements in A cross A that are required to be added to the relation R to make it a symmetric relation. Then m plus n is equal to. So 4x is less than 4x is less than or equal to 5y. It means that x by y that is less than or equal to 5 by 4. It means x by y that should be less than or equal to 1.25. So therefore, the relation R that will be, so I can take 1 comma 1, 1 comma 1 I can take, and we can take and we can take 1 comma 2 also, since y 1 by 2 is half, and we can take 1 by 1 and comma 3 and 1 comma 4 and 1 comma 5 also. And with 2 I can take 2 comma 1 also, 2 comma 2 comma 1 we can't take, since by 2 by 1 will be more than 1.25. So 2 comma 2 we can take, 2 comma 3 we can take, 2 comma 4 we can take, and 2 comma 5 we can take. And we can take 3 comma 1 we cannot take, 3 comma 2 also we cannot take, since 3 by 2 is 1.5, which is more than 1.25. 3 comma 3 we can take, 3 comma 4 we can take, and 3 comma 5 we can take. And with 4 we cannot take 4 by 3 also, since 4 comma 3 we cannot take, since 4 by 3 is 1.33, which is more than 1.25. So 4 comma 4 we can take, and 4 comma 5 we can take. And with 5 we cannot take 5 by 3, 5 comma 3 we cannot take, but 5 comma 4 we can take. 5 comma 4 we can take, since 5 by 4 is equal to 5 by 4, and 5 comma 5 we can take. So these are the elements in the set R. So therefore M is the number of elements in the set R. That will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So M is equal to 16. And then we have to make it a symmetric relation. Now as you can see that this R, it is not symmetric. Since why? Um, if X is related to Y, it also implies that Y is related to X. Then only I can say, then only R is a symmetric relation. R is a symmetric relation. So now here as you can see, 1 comma 2 is there, but 2 comma 1 is not there. 1 comma 3 is there, but 3 comma 1 is not there. 1 comma 4 is there, but 4 comma 1 is not there. 1 comma 5 is there, but 5 comma 1 is not there. 2 comma 3 is there, but 3 comma 2 is not there. 2 comma 3 is there, 3 comma 2 is not there. 2 comma 4 is there, but 4 comma 2 is not there. 2 comma 5 is there, but 5 comma 2 is not there. And here also 3 comma 4 is there, but 4 comma 3 is not there. 3 comma 5 is there, but 5 comma 3 is not there. Okay. So therefore the elements from the set A cross A that has to be added, that have to be added to the relation R, so as to make it the relation R a symmetric relation. So as to make the relation R a symmetric relation, R that will be mm, so we have to add 2 comma 1, we have to add 2 and 3 comma 1 also we have to add, 4 comma 1 we have to add, 5 comma 1 also we have to add, 5 comma 1 also we have to add, and then 2 comma 3 is there, 3 comma 2 also we have to add, and 4 comma 2 also we have to add, and 5 comma 2 also we have to add, and 4 comma 3 also we have to add, and 5 comma 3 also we have to add, and okay, only these. So it means 1 2 3 4 5 6 7 8 9. So therefore n is equal to 9. So 9 elements have to be added. So therefore we have to find the value of m plus n. M plus n, that will be equal to 16 plus 9. M is 16 plus 9, that is equal to 25. So option C is the correct answer. Then here it is told, let A be the set let A be the set of set n belongs to closed interval 100 to 700 intersection n So it means that we have to take all natural numbers from 100 to 700, and n is neither multiple of 3 nor multiple of 4. Neither multiple of 3 nor multiple of 4. Then the number of elements in the set A is, so A contains all those, so A is what? It is the set, A is the set of all natural numbers from 100 to 700, from 100 to 700, which are not multiples of 3, which are neither multiple of 3 nor multiple of 4, nor multiple of 4. So now, therefore, the number of natural numbers from 100 to 700, that is equal to the number of natural numbers from 100 to 700. So that will be equal to 700 minus 100 plus 1. 700 minus 100 plus 1. Since why here 100 has to be included, this will be 601 elements. 601 natural numbers. Now, the numbers which are multiples of 3, now the multiples of 3 are, one is 102, 3 3 are 9, 3 4 is 12. Okay, 102, then 105, then 108, and so on till till it will be 699. 699. So here how many natural numbers? So therefore here if we count, that will be, so it is an AP with, so it is an arithmetic progression with the first term as 102 and the nth term is 699. So therefore the number of multiples of 3, the number of multiples of 3 are, that will be equal to is so 699 equals to a plus n minus 1 into d. A plus n minus 1 into d. D is 3. So n will be equal to 699 minus 102 divided by 3 plus 1. So this will be equal to, this is 3, 3 2 is 6, 3 3 are 9, 3 3 are 9, minus 3 3 is 9, 3 4 is 12 plus 1. So this will be equal to 233 minus 33, that is equal to 200 and 200. So 200 multiples of 3 are there. And how many multiples of 4 are there? That also we have to find. Therefore, the number of multiples of 4 are, so that will be, so the multiples of 4 are what? So the first term it will be 100. First term is 100. Then we have 104. Then we have 108. And then we will have 700 also. Since we have 4, 700 is also divisible by 4. Okay. So then, so therefore, the number of multiples of 4, so that will be equal to 700 minus 100 divided by 4 plus 1. Since why we can say if this is the nth term, then it will be 700 equals to a plus m minus 1 into d. D is 4. So m will be 600 by 4 plus 1. So this will be 600 by 4 plus 1. So that is 4 ones of 4, 4 5s are 20, 150 plus 1, that is 151. 151 multiples of 4 are there. Now some are multiples of 3 and some are multiples of 4, but some are multiples of both 3 and 4. So those we have to exclude. So therefore the number of multiples of 12 that we have to find, number of multiples of 12. So the multiples of 12 are multiples of 12 are, so 12 nines are 108, 12 eights are 96, and 12 nines are 108. So that would be 108, then plus 12 again, that is 12 tens are 120, 12 elevens are 132, and then we'll go till so 700. If we divide by 12, then we will get 12 5 is 60, 12 6 is 72, 12 5 is 60, 10 0, 12 8 is 96. So 4. So we have to subtract 4. So it is 696. So it will go till 696. So therefore number of multiples of 12, that is equal to 696 minus 108 divided by 12 plus 1. So that will be equal to 696 divided by 12, that will be 58, minus 12 nines are 108 plus 1, that is 58 minus 8, that is 50. That is equal to 50. So now therefore the number of multiples of 3 or 4 from 100 to 700, from 100 to 700, how many numbers are there which are either multiples of 3 or multiples of 4? That will be equal to 151 plus the number of multiples of 4 plus the number of multiples of 3 minus the number of multiples of both 3 and 4, that is multiples of 12, that is 50. So then we will get this is 100, and so this is 351, is 301. So therefore the number of elements in A, therefore now the number of elements in the set A, elements in A, it means which are neither multiples of 3 nor multiples of 4. So that will be 601, 601 minus 301, that will be equal to 300. So therefore option A is the correct answer. And here it is told, let the relations R1 and R2 on the set X equals to 1, 2, 3 till 20 be given by R1 equals to okay, let the relations R1 R2 on the set X be given by, okay, so R1 and R2 both are relations on the set X, so R1 is also a subset of X cross X, and R2 is also a subset of X cross X. So where X is given as 1, 2, 3 till 20, and R1 is the relation which is given as it contains the ordered pairs X comma Y, where 2x minus 3y equals to 2, and R2 equals to, it contains all those X comma Y, it contains all the ordered pairs X comma Y such that 4y equals to 5x. If m and n be the minimum number of elements required to be added in R1 and R2 respectively to make the relations symmetric, then m plus n is m plus n equals. Now m is what? M is the number of elements to be added to the relation R1 to make it symmetric, to make it symmetric relation. Similarly, n is the number of elements to be added to the relation R2 to make it symmetric relation. So therefore, we have to find out the value of m plus n. So now R1, okay, that means 2x minus 3y, that should be equal to 2. So their difference should be equal to 2. So it means that 2x and 3y both should be even, or both should be odd, and their difference should be 2. So therefore, the relation R1 we can take, that will be, we can take 4 comma 2, 4 comma 2, since y 2 4 is 8, 8 minus 6, that is equal to 2. And then we can take 7 comma 4, since y 2 sevens are 14. Hmm, 2 sevens are 14, and 14 minus 3 fours are 12, that is equal to 2. And then we can take 10 comma 6, since y 2 tens are 20, 3 6 are 18. And then we can take 13 comma 8, since y 13 twos are 26 and 3 eights are 24. And then we can take 16 comma 10, since y 2 16s are 2 16s are 32 and 3 10s are 30. And we can take 19 comma 12, 19 comma 12 also, since y 2 into 19 is 38 and 12 threes are 36. So these are the elements in the set R1. So now it is not symmetric. So in order to make it symmetric, how many elements have to be added? So now we should add 2 comma 4 also. Since y, if x is related to y, then it also should imply that y is related to x, then only R is called as a symmetric relation. Then only R is a symmetric rel relation. Now here 4 is related to 2 under the relation R1, but 2 is not related to 4. So it means we should add 2 comma 4 also. Therefore, the elements that are to be added, the elements to be added to R1 to make it symmetric, are, they are, one is 2 comma 4 we have to add, and then 7 4 comma 7 also we have to add, then 6 comma 10 also we have to add, and then 8 comma 13 also we have to add, and then 10 comma 16 also I should add, and then 12 comma 19 also we should add. So it means that m will be equal to 6. Therefore, m will be equal to 6, since why 6 elements we have to add to the relation R1 to make it symmetric. Now, the relation R2 we have to find R2, that is equal to, so x is related to y if x by y, that is equal to 4 by 5. So here x by y, that should be equal to 4 by 5. So it means we can take 4 comma 5. 4 comma 5 we can take, and x has the set, x is the set 1 2 3 4 till 20. So we can take 4 comma 5, or we can take 8 comma 10. 4 is 8. Then 3 4s are 12. So 3 5s is 15. So 12 comma 15. And we can take 4 4 is 16. 16 comma 20 also. So till here we can take. Since why we cannot take any element which is more than 20. X or Y should be always less than or equal to 20 only, since it should be in the set X. So therefore here also, as you can see, it is not a symmetric relation, since 4 comma 5 is there but 5 comma 4 is not there. 8 comma 10 is there but 10 comma 8 is not there. So therefore the elements that should be added, the elements to be added that should be added to the relation R2 to make it symmetric. To make it symmetric R, we have to add 5 comma 4, and we have to add 10 comma 8, and we have to add 15 comma 12, and we have to add 20 comma 16 also. So therefore 4 elements we have to add. So it means n will be equal to 4. So 4 elements we have to add. And then it is told that then m plus n equals. Therefore we have to find the value of m plus n, that will be equal to 6 plus 4, that is 10. So option D is the correct answer. Then here it is told that let a relation R on the set n cross n. So R is a subset of n cross n. R is a relation on the set n where which is defined as x1 comma y1 is related to x2 comma y2 if and only if x1 is less than or equal to x2 or y1 is less than or equal to y2. Then consider the two statements. R1 is reflexive but not symmetric, and R is transitive. Then which one of the following is true, that we have to find. So we have to find if this relation is symmetric, this relation R is reflexive or symmetric or transitive or not. So if it is reflexive, then we have to solve it like this. Mm. So it means that for having reflexive relation, x1 comma y1, that should be also related to x1 comma y1. Now this implies that x1, as we know, that is obviously less than or equal to x1, it is true. And or y1 is less than or equal to y1, that is also true. So it means therefore R is reflexive relation. R is a reflexive relation. And then for having symmetric relation, we should have if x1 comma x2, if x1 comma y1 that is related to x2 comma y2, this also implies that x2 comma y2 also should be related to x1 comma y1. So now therefore now if x1 comma y1 is related to x2 comma y2, it means what, x1 is less than or equal to x2 and or y1 is less than or equal to y2. Now x2 comma y2 is related to x1 comma y1. It means that x2 should be less than or equal to x1 or y2 is less than or equal to y1. Now which may be true or may be not. For example, if you take like 1 comma 2 is related to 3 comma 4. Since why? Since 1 is less than or equal to 3 or 2 is also less than or equal to 4, which is true. Uh, uh, but here, 3 comma 4 is not related to 3 comma 4 is not related related to 1 comma 2. Since why? Since 3 is not less than or equal to 1, or 4 is not less than or equal to 2. So it means therefore R is not reflexive. No, R is not symmetric. R is not a symmetric relation. Now, so it means R is reflexive but not symmetric. So the first statement is obviously true. First statement is true. Now we have to check if it is transitive or not. Transitive or not. So now for transitive, the rule is that if x1 comma y1 is related to x2 comma y2, and also x2 comma y2 is related to x3 comma y3, then it implies that x1 comma y1 should also be related to x3 comma y3. So which will not be true, since y, suppose for example if we take the ordered pairs, if you take the ordered pairs, which is if you take the ordered pairs, so any natural number we can take, since R is a subset of n cross n, so any natural number can be taken. So let's take the ordered pairs 3 comma 9, 4 comma 6 and 2 comma 7. Now as you can see, 3 comma 9 is related to 4 comma 6. Since why? Since 3 is less than or equal to 4, or 9 is less than or equal to 6, which is true. Since the second part is not true, but since here or function has been used, or is written, so it means that if any one of them is true, then the whole statement will be true. So it means 3 is less than or equal to 4, so it is true. And also you can see that 4 comma 6 is also related to 2 comma 7. Since why? Since 4 is less than or equal to 2, which is not true, but and or 6 is less than or equal to 7, which is true. So since any one of them is true, so it means the entire statement will be true, since here or function has been used, the or has been used. If here and had been used, then we would have said that if any one of them is false, then the entire statement will be false. But here, since or function is used, so since any one of them is false, and one of them is true, so the entire statement will be true. Now so these two statements are true, but 3 comma 9 is not related to is not related to 2 comma 7. Since why? Since 3 is also not less than or equal to 2, or 9 is also not less than or equal to 7, so this statement is false. So it means that 3 comma 9 is not related to 2 comma 7. So therefore I can say that R is not transitive. R is not transitive relation. So it means statement 2 is false. So only one is correct. So option D is the correct answer. Then here it is told, consider the relations R1 and R2 defined as A R1 B. A is related to B under the relation R1 if and only if A square plus B square equals to 1 for all A comma B belongs to R. A square plus B square equals to 1 for all A comma B equals to for all A comma B belongs to R. So it is so this R is the set of all real numbers, set of r- real numbers. Now, and A comma B is related to C comma D under the relation R2 if and only if A plus D that is equal to B plus C for all A comma B comma C comma D that belongs to n cross n, which is so here A B C D, these should be natural numbers. These should be natural numbers. So here it is said that then R1 and R2 both are equivalence re- relation. So which one is an equivalence relation that we have to find? So equivalence relation means which should be both, means which should be reflexive also, symmetric also, and transitive also. Equivalence relation means it should be reflexive, symmetric, and transitive. Reflexive, symmetric, and transitive. Now, so here it is told a square plus b square should be equal to 1. It should be reflexive. So for reflexive, as you know, for reflexive, um, A should be related to A under the relation R. Then only R is called a reflexive. Now, so if A comma, so I can say that if A comma A belongs to the relation R1 for all A belongs to R, then only I will say that R1 is reflexive. Now, A square plus A square equals to 1. If then I can say that A square should be equal to 1 by 2, then A will be equal to 1 by plus or minus 1 by root 2. So it is only true for 1 by root 2. But for for all real numbers, it is not true. So it means that R1 is not reflexive. R1 is not reflexive. So it will not be an equivalence relation also. It will not be an equivalence relation also, since it has to be all the three. It has to be symmetric also, transitive also, and reflexive also. So since R1 is not reflexive, so it will obviously not be an equivalence relation. Now for R2, therefore we have to check for uh, R2 if it is reflexive or not. So for reflexive, for R2 we should have that this A comma B that should be related to, if A comma B is related to A comma B, then only we can say, then only R2 is reflexive. R2 is reflexive. So now A comma B, now therefore now, as you know, A comma B is related to C comma D if A plus D equals to B plus C. So for all natural numbers n. Okay. So now, therefore, A plus B, that will be obviously equal to A plus B. So it means that R2 is reflexive. So it is true for all A comma B belongs to the set of natural numbers. So therefore, obviously, R2 is a reflexive relation. Reflexive relation. So R2 is reflexive relation, and then for symmetric we should have that if a comma b is related to c comma d, then c comma d also should be related to a comma b for all a comma b comma c comma d belongs to n. So now here it is told that if a plus b a plus d equals to c plus b, then obviously we can say that c plus b equals to a plus d. So hence we can say R2 is a symmetric relation. R2 is symmetric relation. And then for transitive, we should have that if a comma b is related to c comma d, and also c comma d is related to e comma f, then we can say that a comma b will be related to e comma f for all a b c d e f belongs to the natural number n. So now here you can say that if a plus d that is equal to b plus c, and c plus f that is equal to d plus e, then we can say that a plus f that is equal to, okay, c plus f that is also equal to d plus e. Okay. Now then a plus f we have to find if it is equal to b plus e or not. So a plus f and b plus e we get. So if they are same or not, that we have to find out. So now, so if we add these two equations, then we can say that a plus d plus c plus f that will be equal to b plus c plus d plus e. So now here c plus d we can cancel them. Then we can say that obviously a plus f that will be equal to b plus e. So obviously b plus a plus f also will be equal to b plus f. So therefore R2 is transitive relation also. R2 is transitive also. And since R2 is reflexive also, symmetric also, and transitive also, so therefore we can say that R2 is an equivalence relation. R2 is an equivalence relation. So option C is the correct answer. Then here it is told that if R is the smallest equivalence relation on the set A, which is, so R is a relation on the set A. So R is a subset of A cross A, where A is 1, 2, 3, and 4, such that okay. So R is the smallest equivalence relation. It is also an equivalence relation, and such that the ordered pairs 1, comma 2 and 1, comma 3 also belong to the set R, or I can say the set 1, comma 2, 1, comma 3 is a subset of R. So then we have to find the number of the elements in set R. Number of elements in the set R that we have to find out. So now, therefore, the set R, it should obviously contain 1, comma 2 and 1, comma 3. So then, since it has to be reflexive, so it should contain 1, comma 1, 2, comma 2, and 3, comma 3 and 4, comma 4 also. Since why it should be reflexive? These elements should be there since it should be reflexive. And since it contains 1, comma 2, it should also contain 2, comma 1. And since it contains 1, comma 3, so it should contain 3, comma 1. Since why it should be symmetric relation. And also since it contains 1 comma 2 and 2 comma 3 is not there. Okay, so 1 comma 2 is there, 2 comma 1 is there, so 1 comma 1 is there, 1 comma 3 is there, uh 3 comma 1 is there, so 1 comma 1 is there, so it is transitive also. So therefore this is the smallest equivalence relation on the set A. This is the smallest equivalence relation on the set A. Smallest equivalence relation on the set A. Okay. So therefore the number of elements in the set are that will be equal to 1 2 3 4 7 8, so that is 8. So option D. Yeah, yeah, so option D is the correct answer. Then here it is told that let R be a relation on the set Z cross Z, where Z is the set of all integers. So then A comma B is related to C comma D, or if and only if AD minus BC that is divisible by 5. Is divisible by 5. So R is a subset of Z cross Z. It is a relation on the set Z. So here AD, AB, CD, all this should belong to the set Z. Then R is reflexive and transitive but not symmetric. So we have to find that if it is reflexive, symmetric, or transitive. So now for reflexive we should have, that is A comma B should be related to A comma B for all A comma B belongs to Z. So now uh, so AB minus AB minus AB, that is equal to 0. So which is obviously divisible by 5, which is divisible by 5. So it means that R is reflexive. R is a reflexive relation on the set Z. And then for symmetric relation, for symmetric we should have that A comma B, that should be, if A comma B is related to C comma D, then this also implies that C comma D also should be related to A comma B. So now therefore if AD minus BC is divisible by 5, is divisible by 5, it means what? That I can say that AD minus BC is equal to some 5m for some m belongs to Z, for some integer Z. Then uh, then we can say that uh, that BC minus AD, that will be equal to minus 5m. So it means that that B comma C will be also, sorry, so C comma D will also be related to, so it means that C comma D also will be related to A comma B. So hence we can say, hence R is a symmetric relation also. R is a symmetric re- relation also. And transitive, for transitive we should have that uh, transitive we should have that if A comma B is related to C comma D and C comma D is related to A comma B, no, C comma D is related to E comma F, then it also implies that A comma B should be related to E comma F also. Now we have to check if it is true or not, and which should be for all A comma B comma C comma D comma E comma F belongs to Z. So we have to check if it is true or not. So now hence we can say that we have to assume that AD minus BC is divisible by 5, and also CF minus DE is also divisible by 5. So therefore we can say that AD minus BC, that is equal to some 5m, and CF minus ED, that is also equal to some 5n for some integers m and n. For some m and n belongs to Z. So now AF minus BE, AF minus BE so now AF minus BE may or may not be divisible by 5. May not be divisible by 5. Since why? Since for example, suppose we take the numbers uh, 3 comma 1, that is related to 10 comma 5, and 10 comma 5 is also related to 1 comma 1. Since why? Since 3 5s are 15, 3 5s are 15, and 1 into 10. So 15 minus 10, that is equal to 5, and also 10 into 1 minus 5 into 1, that is 10 minus 5, that is also equal to 5. But 3 comma 1 is not related to, it's not related to 1 comma 1. Since why? Since 3 into 1 minus 1 into 1, that is equal to 2, which is not divisible by 5, which is not divisible by 5. So hence, so I can say that R is not transitive relation. R is not transitive relation. So therefore, the relation R is reflexive and symmetric, but not transitive. Reflexive and symmetric, but not transitive. So option B is the correct answer. So here it is told that let A and B be two finite sets with m and n elements respectively. The total number of subsets of the set A is 56 more than the total number of subsets of set B. Then the distance of the point P m comma n from the point Q minus 2 comma minus 3 is. So therefore, as we know, the number of subsets of a set having n elements is given as 2 power n. is 2 power n. So therefore the set A has got m elements and set B has got n elements. So therefore it is told the total number of subsets of set A is 56 more than the total number of subsets of B. So it means therefore 2 power m is the number of subsets of A minus 2 power n, that is the number of subsets of B, that is equal to 56. From here, so it means obviously m is more than n. So therefore we can take 2 power n as common, then we will get into 2 power m minus n minus 1 equals to 56. So 56 I can say this is 7 into 8. So therefore we can tell 2 power n equals to 8 and 2 power m minus n minus 1, that is equal to 7. So therefore 2 power n equal to 2 power 3. So therefore n equal to 3 and 2 power m minus n, that is also equal to 8. It is 7 plus 1 means it is 2 power 3. So therefore m minus n, that is also equal to 3. So m equal to 3 plus 3, that is 6. So m equal to 6. So therefore point P is the coordinates of the point P is 6 comma 3 and point Q is minus 2 comma minus 3. So therefore you have to find the distance of point P from the point Q, means the distance PQ we have to find out. PQ will be equal to square root of 6 minus of minus 2 whole square plus 3 minus of minus 3 whole square. So that is equal to 6 plus 2, that is 8 square, plus 3 plus 3 is 6 square. So that is square root of 64 plus 36, which is root over 100, that is equal to 10 units. So 10, option B is the correct answer. And here it is told S, the set S is 1, 2, 3 till 10. And suppose M is the set of all the subsets of S, then M is the set of all subsets, means M is the power set of S. It is the power set of the set S. Since why? It is the set of all subsets of S. Then the relation R, which is it consists of the sets A, comma B, such that A intersection B, that is equal to phi. It means they are A and B should be disjoint sets, and A comma B belongs to M. So A and B both should be subsets of S, and A intersection B should be phi. So is it symmetric, reflexive, or transitive? That we have to find out. Therefore, now for reflexive, should have that for reflexive we should have that A comma A should belong to the set R. So now A intersection A, that is not phi. So therefore the relation R is not reflexive. And for symmetric, we should have that if A comma B belongs to the relation R, then B comma A also should belong to the relation R. Sorry, B comma A also should belong to the relation R. Then only I will tell R is symmetric. Now, if A intersection B is phi, then B intersection A also will be equal to phi only, since A intersection B and B intersection A is same. So therefore R is obviously symmetric. R is a symmetric relation. Symmetric relation on the set M. And for transitive we should have that if A comma B belongs to the relation R and also B comma C belongs to the relation R, then A comma C should also belong to the relation R for all A comma B comma C belongs to the relation M, where M is the set of all subsets of S. Now, if A intersection B that is equal to phi, then A comma B belongs to R. And also, if B intersection C equals to phi, then also B comma C belongs to relation R. Then A intersection C, B intersection C is also phi. Now we can't say that A intersection C may not be phi, may not be an empty set. For example, if we take A is a set of some subsets of S. So A is a subset of S and B is a subset of S. So the set S is 1, 2, 3, 4 till 10. So let's say A is 1, 2 and B is suppose 3, 5 and C is suppose 2, 7. Then A intersection B that is equal to phi and also B intersection C that is also equal to phi, but A intersection C equals to 2, which is not equal to phi. So therefore, R is not transitive. R is not a transitive relation. So R is only symmetric. So R is symmetric only. So option A is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year exam on sets and relations of JEE Mains. Still any doubts if you have, then please write that in the comments. We shall obviously clarify them, and please install our Sapience Education application where we shall upload some important questions based on the previous year questions on every chapter of maths. Still, which shall be obviously helpful for your exam. So thank you everyone. Bye.